that hopefully the idea of print is somewhat easier than the idea of this insert, which was like it's much harder to explain what it does rather than look at this code and say, okay, there's one pointer, there's another pointer, there's one pointer, there's another pointer. Let's just link everything together and we have a list. But the challenge is that there is an insert. So we're potentially manipulating not 2, but 3 elements. Because if, like, as we started with this, if A was already pointing to C, then inserting B in front of A involved step number 1, making sure that B points to C, and step number 2, now A can safely point to B. Right? And we cannot do it in other direction because this value right here cannot be this value cannot be lost, because at this point when we're trying to insert, if A already points to C, we cannot lose this pointer. We must take this value and immediately make B use this value to point to another node, which was previously on the list, and then safely say, okay, we know what the address of B is and of node B is, and then point it here, which happens on the second line. All right, so let's see. Let's try another function before we take a break. Hopefully, it'll get easier as we move along. I think that print is already somewhat easier to understand than insert. So the next challenge is, can we also provide remove? All right, let's try this before the break. So we have this idea that we can tell the node, remove something from the list. Remove the next element. By the way, as demonstrated on this diagram, if we have node A pointing to B pointing to C, exactly what we have, and then if we say node A remove next, it's not like we're unlinking A from the list. Instead, we're removing one element from the list, just one element from the list we're removing, and making sure that A now pointing to whatever was next. So again, this. Let's take a look, and I will just so that we have time for other things. We can take this implementation and basically copy and paste. How about I just make sure that I have a placeholder for this function. Right, so this is our implementation file. This is our header file. So remove next is next challenge to have and understand. So remove next implementation is here, node, the node, and so its implementation here is made of these things. So let's take a look at what this does, and maybe we can now modify it so that everything is nice. So let's see what is going on. This is the way it's going to look like. We just say node A dot remove next. That's all, and then we can say print again. So we should so B will be gone from this list by the time we call print the second time. All right, so that's the expectation. Let's see. So first we say if node A, so we just let's keep this in view. Let's keep both of them in view. We say node A remove next. So remove next is invoked on this node. And we say if you're pointing to nothing, then there's nothing to do. There's nothing to remove. There's no error of any sort. We just say this is it, done. This remove next should do nothing, right? So the next one doesn't exist. Forget about it. All right. However, so if this I don't know why it's so unhappy and does something here. Let me, I don't know. Let's find out. Well, first of all, real quick, let me just go to properties and make sure I remove those crazy warnings. C++, general enable warnings. I'll go back to the default. How about level 4? Let's try this level 4 warnings. All right, build. So I got some errors. Pnext undeclared identifier. What am I using here? Pnext. Oh, pnode, not pnext. So I call it pnode. So let's replace everything with pnode instead of pnext. It's just naming. Okay, that's good. One more, thank you. Yes. So now let's try it again. Try again to talk about it. Make sure we build properly. Everything builds, no problems. So remove next. So remove next says, all right, if like in case if the next node does exist, then we'll declare it obsolete, right? So essentially right here, this is obsolete, right? It's no longer should be part of the list. So we name it obsolete. Then we say this node, the p node, and I can actually get rid of this. This is not necessary, but maybe this is easier to interpret. We'll talk about it. So if this node, which is node A, used to have something, then this obsolete node does exist. It does exist. So let's grab whatever it's pointing to and make sure that this node is now pointing to. In other words, as a result of this, A will be pointing to C, because this is A pointing to whatever B used to know it's pointing to. So now A pointing to over here. This is a pointer to C, and we get it and we assign it to node A. And then we say make node single. Basically, we don't want node B, which is now excluded from the list. We don't want this node B to mess around with our list. And we say, hey, your P node should be null. You're no longer, not just that we don't know anything about you anymore, but also you should not know anything about us. So we kind of chop this pointer away from B, and it's pointing to null. It becomes separate from this list. So A now points to C, and B is single again, as it was first when it was created. It was created single. It was pointing to no other nodes. So that's the result. And let's make sure that if we run this, the second time it prints 1, 1, and 3, 3. So 2, 2 is gone from this output. After this, it becomes quite easy, because those are the two functions that are really challenging. Let's talk about the technicalities and the two functions together. Let's first of all, let me get rid of all these comments. They're not very useful at all. Now these comments, maybe when I have comments that run away like this, I simply put them like this in the code and format all of this. Similar with this line, let's make sure that it all becomes visible. So it's like step 1, right? Step 1, let the new node, and I don't know how B is useful here, let's just get rid of it. Let new node point to whatever this node, just say is pointing to, why we use past tense, is pointing to, and let this node point to the brand new node of the list, right? So similarly here, let's move this print function down so that so we can keep remove and insert together. So here we say if no other, basically if this is the tail of the list, Again, I run out of space, so I'll be just doing this. If this is the tail of the list, then nothing to do, right? So return. Otherwise, we have a pointer to the next one, which now becomes obsolete, and we say then that this really exclude obsolete, right? Because this very line, what it does, it goes right here and does this, right? It says whatever B is pointing to, now A will be pointing to, and you're gone. You still have this little piece remaining, but we're going to take care of it as well by setting it to null, right? But this is what this line does. This very line, that's what it does. So let me just save this, make sure we don't lose it.